Hello, my name is Zoe Bartliff and I'm in the final stages of my PhD at the University of Glasgow in the Information Studies Department. What I'd like to talk to you about today is the use of semantic textual encoding and its role in supporting the navigation and analysis of medieval texts. My particular area of interest is medieval Wales, so I'm going to focus on the text that I've used as the core of my thesis, and that is the medieval Welsh legal text, Cyfraith Hywel. To start, and to give a bit of background information both my thesis and my talk today, Cyfraith Hywel is first extant from the 12th century, approximately the time of the Anglo-Norman invasion in Wales. But there are some elements that could potentially date back much earlier than that. They are exceptionally important texts, both within the context of medieval Welsh culture, but equally they are essential from a modern perspective, to allow us to gain an insight into not only the Welsh legal system, but also some elements of culture and society, as it is one of the only texts portraying an internal perspective of the day-to-day life within Wales. Beyond this, there are approximately 80 manuscripts, making it one of the most prolific within the medieval Welsh corpus. Of the 40 or so that were produced whilst the Welsh law was still active, only 2 have been judged to be identical, with each of the others demonstrating some form of evolution that sets it apart from the rest of the corpus. This can give us a diachronic overview of not only how the medieval Welsh language changed throughout the period, but also the cultural and legal changes that may have been impacted through the course of this exceptionally turbulent time. Now, despite the importance of these texts, research into them has come to somewhat of an impasse. Because there is a large volume and such great complexity in the material, there has regularly been the need to either aggregate the text into a single edition using a header text or an exemplar as the main source, and then adding additional notes to indicate variations in different manuscripts. This, of course, leads to a loss of material and a loss of a lot of the uniqueness of each manuscript. An alternative method is to get a horizontal view of the material by focusing on a specific sample, such as a passage for close reading, and this is drawn from multiple manuscripts. Again, this results in some loss of data, but it gives a great insight into a particular aspect of the material. What I'm investigating with my research is that Cyfraith Hywel and indeed other medieval manuscripts might be treated as large-scale datasets. These datasets have been the focus of data analysts for some time, whether those be textual data or numerical data or any kind of data. And the result is a great array of methods to search, sort and filter through the material and extract useful results. In order to accomplish this, I'm suggesting a use of XML encoding, which is a method of textual markup that allows for a layer of metadata to sit alongside the text, flagging data points of importance and providing additional computer-readable information, which for my thesis includes lemma forms, grammatical breakdowns, hypernym categorization, as well as structural features such as where there are sentences or paragraphs. These structural measures have also been used to demarcate between the tractates of the text, which is to say the thematic subsections of law, as well as the broader groupings of these tractates into books. Although a degree of automation was achieved for the building of an auto-populating dictionary, the encoding was a quite long-winded process, primarily manual at this point, as there has been little work done on the automatic identification and lemmatization of medieval Welsh texts, and that work that has been done has been quite localized to specific geographical regions or time periods. Despite the time taken, my research has shown the great benefits of engaging with the text in this way. For the long term, the availability of a hand-coded dataset in combination with a dictionary have the potential to contribute towards machine learning systems intent upon the automation of this process. In the short term, however, the benefits are equally as great, as it makes the text computer readable. This in turn leads to the second part of my methodology, namely the application of digital humanities methodologies, such as statistical language processing techniques. This provides a unique insight into the text that is not available through other methods. In particular, it allows for the identification of overarching patterns within and between the manuscripts. The methods I have chosen to share today are a veritable tip of the iceberg in terms of the potential that's possible with computer-readable text, but I hope it will give an insight into these possibilities, as well as inspiration to take this kind of work forward. In total, I've encoded 26 out of the 40 manuscripts that were created while the law was still active in medieval Wales, which amounts to a corpus of about 800,000 words. An example of the encoding is given on the right-hand side of the screen, and you can see that it gives a breakdown of what part of text it is, namely the introduction, then that it is a paragraph and a sentence, and then for each word it gives a full grammatical breakdown. On the left-hand side is diagrammatic breakdown of the corpus, showing that it's first divided into redactions, meaning the four primary groupings of the Cyfraith Hywel tradition, and then into manuscripts. Within the manuscripts, the legal text is subdivided into books, namely the law of the courts, the law of the country, which are then further subdivided into tractates, each of which treats a specific feature of the law. The highest granularity measures are, of course, the paragraphs and sentences and the word itself. By imbuing the text with this structure, it's possible to explore the text as well as at whatever level of granularity suits the present research questions. So you can either examine the corpus as a whole, as I have for you today, or look at a single manuscript or a single book within the corpus or across all of the manuscripts. In short, there is a massive amount of flexibility. Furthermore, as the XML is computer readable, it's possible to use the elements of encoding as flags for the computer to analyze. Engaging these, it's possible to retrieve frequency counts for tokens, lemmas, or the categories of these, such as all the lemma forms that are related to the ruling classes, to give an example of one of the hypernym categorizations used in this corpus. So to move on to some of my findings, this sunburst diagram on the left is animated to give an approximation of the interactive nature of the live visualization, as it allows you to refocus on specific segments. It's intended to give an indication of the contents of the corpus broken into subsections to represent the different manuscripts and then again to the books inside them. The segments are sized proportionally to the contents that they represent. So as an initial finding, these segments confirm that there is a high degree of individuality for each manuscript in terms of length. Further to this, it suggests that the groupings into redactions is perhaps not wholly reflective of the contents of the manuscripts. Take, for example, the blue Bartliff manuscripts, which displays the greatest range of the corpus. Another way of reviewing this data is the histogram on the right-hand side. The blue Bartliff texts span the range of the corpus, as do the Cyfraith texts, the red ones, whereas the Latin and the Cyfraith, the traditions regularly considered the most disparate, are quite closely grouped together. These visualizations give an innovative perspective on the distribution of the material, whilst also starting the process of narrowing down where there might be some similarities and differences in the texts, allowing certain manuscripts to be marked for further consideration. Most importantly, however, is that the redactions do not show the internal consistency that might be expected of text groupings that have long been considered as a family. Beyond the purely frequency-based statistics of the previous slide, it's possible to arrange the manuscripts on a standard deviation box plot in order to see the statistical distribution of the material. The top right shows the distribution of unique tokens between the different redactions. You can see that the most variety can be found again within the Bartliff and Latin manuscripts, whereas the Cyfraith are very localized and very similar to one another in terms of language variety. Conversely, the encoding has also allowed for the extraction of lemma forms, which is to say the dictionary entry for each word. This allows us to remove the variation that results from morphological and orthographical mutations of the words. This results in a much more focused and accurate representation of the language variety. Here the picture is quite different from the pure token analysis, in which in and of itself highlights the importance of being able to access the lemma forms, and consequently the significance of the encoding process for analysis. In this graph, the Cyfraith texts display the greatest variety in language compared to the other redactions. This might be suspected to be a consequence of the length of the manuscripts, as the Cyfraith texts are on the longer side, suggesting a greater variety of material. However, if this is the case, it should also be reflected in the Bartliff text, but this doesn't appear to be the case. To investigate the relationship between text length and language variety more closely, the manuscript's unique lemma counts have been plotted on a scatter graph. There is a general upward trend to be found between the two, indicating that a longer text equals the greater variety in lemma forms. It's also possible to see that Latin texts have a much steeper trend, most probably due to the mixture of Welsh and Latin language elements within them. The Cyfraith texts, however, defy this trend, with little patterning between the rising text length and the lemma count. This is not something that can be accounted for directly through these statistics or these visualizations, but it's a curiosity that would not necessarily have been seen without the underlying encoding of this corpus and the associated statistical language processing. Another measure that is possible to extract from the corpus is a Euclidean vector analysis. So what this does is it takes each word within the corpus, in this case the lemma forms, so as to avoid skewing the results, and with stop words removed as is standard for this kind of analysis. And it then compares each of the words to each other word within each other manuscript in the corpus. Thankfully this is done via the computer, as it takes a lot of calculations to do manually. Displayed in this graph is the cosine similarity, which is the inverse of the vector analysis and gives a measure between 0 and 1, with 1 representing the complete similarity. It's quite clear from the heat map, which shows the degree of similarity, that the Latin manuscripts are causing a bit of a barrier to analysis. This is quite understandable, as each Latin word is clearly quite different from the Welsh language words. So to remove these, it's possible to see that on the Welsh language only heat map that there are some distinct patterns that emerge from the figures. So we can add in the redaction guidelines. The first of these is that despite some differences, there is a sufficient degree of similarity to indicate that each of the texts do indeed have a shared core. However, the Blegrith and Cyfraith manuscripts, which are the second and third columns respectively, on the whole achieve a much higher rate of similarity, both within their own redactions and in comparison with one another, supporting the claim that these texts have historically been related to one another. There are, however, some exceptions to this. MK, which is this one, for example, actually appears to be much more closely related to the Iorwerth text than the Cyfraith or Blegrith. The Iorwerth manuscripts, however, defy the rest of the tradition. They are very different, and they are most distinct in the corpus, with the lowest amount of internal consistency, as well as in comparison with the other two redactions. Manuscript D, in particular, stands out as particularly distinct. To approach these measures from an alternative perspective, the Euclidean measures can be arranged on a dendrogram, which is a tree diagram, to show at what measure the different manuscripts diverge from one another. This dendrogram further enforces what can be seen in the heat map with regard to the broad groupings between the manuscripts. There are two primary branches in the tradition, with the Iorwerth breaking quite high from the rest of the group. That's this set here. The Iorwerth is then further subdivided, with A and C forming one group, and E, B, and D a second. The other branch is a complete intermingling of the Cyfraith and Blegrith manuscripts. For example, W, V, and X, which are part of the Cyfraith, seem to form their own grouping, closer to R, N, and J than the other manuscripts, even within their own redaction. Conversely, U and K are linked to a complete different sub-branch that contains the other manuscripts of the Blegrith texts. So that's these ones right here. So to conclude, I hope I have shown with this presentation that encoding in this manner is a foundational step towards the accurate incorporation of digital humanities methods with medieval texts. Whilst a time-consuming process, the flexibility that it lends to textual analysis allows and even encourages a wealth of new questions, whilst also providing avenues to investigate their answers. Furthermore, work of this kind can be engaged to develop semi-automatic or perhaps at some point fully automatic encoding software, which, by training machine learning models on manual encoded data, greatly increases the speed and accuracy of similar encodings for future works. Beyond this increased access to the texts, the incorporation of statistical methods with more traditional approaches such as close or comparative reading allows for an increased transparency and replicability of studies. Statistical methods provide a shared language and a shared baseline of knowledge upon which scholars can build their interpretations and conclusions of the text, limiting the need for estimates of scope or the projection of conclusions based on a small sample to the text or even corpus as a whole. They also allow for the identification and analysis of patterns that occur on scales which would otherwise have been unseen through manual analysis, whether that be on the level of the corpus as a whole or on a single lemma form in its appearances across the texts. For manual analysis, there is a necessary reliance on the instance of discovery as a method of access, and that can all too easily be inconsistent, whether through an incomplete sample or a missed data point. It is important to remember, however, that these digital methods are a supplement to manual analysis rather than a replacement. I think this is perhaps summed up in this quotation. Thus, the ideal role of the computer and the purpose of computing in digital humanities is not to make research better, faster, and/or cheaper. On the contrary, as a number of writers have argued, computing should be about making problems more difficult, more complex, and more thrilling. Computing is, or can be, a telescope for the mind. Thank you for listening.